Hello everyone. This video is focused around understanding the Azure environment traffic flow and understanding why do we need network virtual appliances and how you can actually use our network virtual appliances in a Azure environment or similar concepts apply to other public clouds as well. So let's get started. Hello everyone. This video is focused around understanding Azure environment and understanding specifically the traffic flow within the Azure environment. This video also talks about why do we need network virtual appliances, and it also brings together basics of how you can use a network virtual appliance. So let's get started. Okay, so in terms of Azure environment, the very first thing you would have in your Azure subscription is a tenant. So you would be one of those tenants, or you might have child subscriptions which will be child tenants. So inside that subscription you would have one or more than one VNets. You can potentially have a number of VNets into different regions, but here in this example we are focusing on Azure VNet 1, and I have assigned that VNet a subnet or a range of 10.0.0.0/16. Now inside that VNet, or I would say inside that Azure cloud, that VNet is running on some core computing power. That core computing power is Azure host, or I would say physical tins, maybe from XYZ vendors, and those tins are actually running Azure hypervisor. Now Azure hypervisor spans across multiple tenancies, so that's why in this diagram it is showing as extending beyond your tenancy. Now inside that Azure environment or Azure hypervisor, you would be creating subnets. That subnets would be part of the VNet range. So let's say we create a subnet 10.0.1.0/24. When you create a 10.0.1.0/24 subnet, the Azure environment creates a SVAI, which is a layer 3 virtual interface on the Azure hypervisor. Azure hypervisor in this case acts like a distributed router. So this SVI is created on the hypervisor layer, which spans across different hosts, but obviously it spans only in your tenancy or your VNet. Then similarly I would create two more subnets. The two more subnets are 10.0.2.0/24 and 3.0/24. Now what happens is, in a normal traffic flow, a packet coming from 10.0.1.0 will hit the SVI, which is the default gateway, and reach the destination, and the destination could be another subnet in the same VNet, or it could be another subnet into a different VNet. So it will have to cross to the Azure hypervisor layer. Now when it crosses the Azure hypervisor layer, each subnet which you have created is a directly connected subnet. Since it is a directly connected subnet, Azure hypervisor can route between the subnets, so you don't have any security between those two subnets. So basically traffic comes from one subnet, goes to the other subnet. What you can do is use network security groups, but those are like access control list, nothing more than that. If you need next generation firewalling feature, they can't help you, and you will have to look for network virtual appliances. So you might have more VNets. In this example there is another VNet here, and you might have peering in between these VNets, and the same concept applies to the other VNets as well. So let's see now how do we use network virtual appliance to secure communication, or to provide perimeter firewalling, as well as to provide internal segmentation. Okay, now let's look at how do we secure the Azure environment from perimeter firewalling as well as internal segmentation point of view with Fortigate. So we have this high-level diagram, or I would say conceptual diagram in here, wherein there is a Azure tenant. This tenant would be again your subscription. Inside this tenant I have a VNet and then 3 subnets. So all these 3 subnets are having an SVI on the Azure hypervisor. So in order to secure this environment, what we do is we provision our network virtual appliance Fortigate, and we have an external interface on the network virtual appliance as well as an internal interface. This internal interface, you can also call it as a redirection interface. And why do I call it redirection interface? You will get to know in a moment. So if a traffic coming from the internet has to go to the DMZ zone in this environment, which is 10.0.1.0, what really happens is the traffic will come to the Azure public IP. Now Azure public IP will be hosted on Azure Load Balancer, and Azure Load Balancer can have a NATing, or you can also have a directly public IP NATed in the background in the Azure environment to your Fortigate firewall external interface. You can NAT it to even virtual IPs, which would be just like a secondary IP onto the Fortigate firewall. So the idea is to push traffic coming from the internet through the NAT to the Fortigate, and then Fortigate receives the traffic and looks up the routing table and sends the traffic towards the internal redirection interface and reaches DMZ. That's all good, but what happens to the return traffic? Now in a return traffic scenario, there could be 2 possibilities. The number one is when the traffic leaves the Fortigate firewall, we can always do a source NAT to the traffic and NAT the traffic to the interface IP of the internal or redirectional interface. So that way the destination will always know that it has to reply back to the Fortigate firewall. In this scenario, destination is 10.0.1.0 subnet, which is the DMZ zone. So DMZ zone will reply back to the Fortigate. However, if you don't really want to use NATing, what you can also do is you can configure a UDR. Exactly is a UDR. UDR is a policy-based routing. So in the Azure terminologies, we define it as a user-defined route, or you can also say route tables in these simple words. Now this UDR will say that any traffic coming from source 10.0.1.0/24 with destination of default has an ex-top IP of 10.0.4.5. So the traffic comes from 10.0.1.0 subnet and goes to hypervisor. Hypervisor sees a user-defined route defined, and it says, okay, you are coming from source 10.0.1.0 destined for default. You have to go to redirection interface. That way you can actually send traffic back to the Fortigate firewall. Fortigate firewall sends it back to the internet. Now this looks good for perimeter firewalling perspective, but what happens for the internal segmentation approach? So you can always use a default route on a UDR, but you can also specify specific routes. For example, you can say a source traffic which is coming from 10.0.1.0 destined to 10.0.2.0, which is again an internal network in here, which is the app layer. Your next hop IP is 10.0.4.5, which is again a Fortigate. So how does the traffic flow look like for an internal segmentation? The traffic comes from the DMZ subnet, passes the UDR. UDR says, okay, go to Fortigate. Traffic received by Fortigate. Fortigate checks its own routing table, and Fortigate will act in this scenario like a router on a stick model, wherein it will receive the traffic on the internal interface and send the traffic back on the internal interface. So you will have to have policies on the Fortigate for received and transmitting traffic on the same interface, and the traffic finally reaches the app layer. This looks all good. However, then again we have to take care of the return traffic. So in this scenario, we will have another UDR which will be placed on the app layer subnet. So this UDR will say, okay, if I have to reach 10.0.1.0, what is my next hop IP? Again, you will define the next hop IP as the internal or redirection interface. So the traffic will actually leave the app layer, go to the Azure hypervisor layer. from the Azure hypervisor layer, it will reach 10.0.4.5, which is Fortigate. Fortigate will do its own internal routing lookup and send traffic back to the hypervisor, and finally it reaches the DMZ network. So that's how you can actually achieve internal segmentation as well. Similarly, you can actually apply a UDR to the DB layer, and same concepts apply. So that's it for this short video. I hope the concept of UDRs and how the traffic flow works in the Azure environment is clear. If you have any questions, please post it and I will be happy to reply back. Thank you.